The telephone network is an integral part of computer communications. Data, instructions, and information are transmitted over the telephone network using dial-up lines or dedicated lines. In this presentation, we will be learning the concepts pertaining to telephony and modem. The outline of the presentation is shown here. Connection-oriented communication session is established before any useful data can be transferred, enabling the ability to ensure that data is delivered in the correct order to the upper communication layer. Circuit switching: two network nodes establish a dedicated communications channel through the network before the nodes may communicate. It is a method whereby a dedicated physical path, or circuit, is established and maintained between two nodes for the duration of a connection. By using a leased line, it is possible to arrange for a channel to be set up permanently between two subscribers. The speech relating to a call that is transmitted over the access line is represented in either an analog form or a digital form. Multiplexing technique is applied to share a scarce resource. With multiplexing, several telephone calls may be carried using one wire. When analog transmission is used over the access lines, the total network is known as a public switch telephone network. When digital transmission is used over the access lines, it is known as integrated services digital network. Portions of the high bitrate lines are also used by a telecommunications operating company to create what are called Internet Service Provider networks. In addition to telephony, a PSTN also provides a number of digital services including fax and access to the Internet. It is because of this reason telephone networks form an integral part of the Internet. When analog transmission is used over the access lines, the total network is known as a public switch telephone network. When digital transmission is used over the access lines, it is known as integrated services digital network. Portions of the high bitrate lines are also used by a telecommunications operating company to create what are called Internet Service Provider networks. In addition to telephony, a PSTN also provides a number of digital services including fax and access to the Internet. It is because of this reason telephone networks form an integral part of the Internet. PSTN and ISDN connect subscribers within a localized area to their nearest local exchange, LA, or end office, EO. These are national networks concerned with the transmission and switching of calls between different regional and national exchanges, offices. These are concerned with the transmission and switching of calls internationally between the different national networks. Associated with each national network is an International Gateway Exchange, IGE. These connect subscribers within a localized area to their nearest local exchange, LE, or end office, EO. Each subscriber within a localized area is connected to an LE or EO in that area by a dedicated circuit by a twisted pair wire cable. This is known as the customer line or, more generally, the subscriber line, SL. These are national networks concerned with the transmission and switching of calls between different regional and national exchanges or offices. In the case of a PSTN, analog transmission is used over each subscriber line, a bandwidth of 200 Hz through to 3.4 kHz. With an ISDN, digital transmission is used over the subscriber line, which is then known as a digital subscriber line, DSL, since all the signals relating to a call are digital. Typical bit rates are 1.5 Mbps, supporting 24 calls, or 2 Mbps supporting 30 calls. These are concerned with the transmission and switching of calls internationally between the different national networks. Associated with each national network is an International Gateway Exchange. Each subscriber within a localized area is connected to an LA/EO, the local exchange EO end office, in that area by a dedicated circuit which, in the case of most homes and small offices, is twisted pair wire cable. This is known as the customer line or, more generally, the subscriber line, SL. Within ISDN, digital transmission is used over the subscriber line, which is then known as a digital subscriber line, DSL, since all the signals relating to a call are digital. As already said, prior to a call taking place, a connection through the network between the two subscribers must be set up, and on completion of the call, the connection is closed down. The setting up and closing down of connections is carried out by the transfer of a defined set of control messages, signaling messages. In the case of an analog subscriber line, the signaling messages are analog signals such as single-frequency audio tones. An ISDN can support 2, or more, calls simultaneously. The signaling messages are allocated a dedicated portion of the bandwidth per bit rate of the line. The transmission system comprises two parts. That used in the local access network, analog or digital, and that used in the trunk network. The type of transmission used in the local access network can be either analog or digital. Although all digital transmission, and switching, is used in the trunk network, for historical reasons, two different types of digital transmission system are used. One is called the Plesiosynchronous Digital Hierarchy, PDH, and the other the Synchronous Digital Hierarchy, SDH, the latter also known as the Synchronous Optical Network or SONET. In ASL, each subscriber line comprises a single twisted pair wire that connects the subscriber network termination to a line termination unit, LTU, in the LA/EO. In practice, the cable used has a number of twisted pairs within it, and, for a home or small business that requires more than one user to be active at a time, more than one twisted pair can be allocated to it. The complete cable linking the subscriber premises to the LA/EO is made up of multiple cable sections with a combined length of up to about 5 miles, 8 kilometers. In order to enable new customers to be added and faults on individual lines to be located, each subscriber line within a localized area is terminated at a junction box. Junction box is located within a few hundred yards, meters of the customer premises within that area. Typically, the cable from a junction box to a cross-connect contains in the order of 50 pairs, and that from the cross-connect to the LA/EO several hundred pairs. For cable lengths greater than the mile, 1.5 kilometers, the individual pairs within these cables are joined to a third set of pairs within an even larger cable. This is done in a roadside cabinet known as a cross-connect. The various components that are present in a telephone are shown in figure. A DC voltage of 48 V is permanently applied to the subscriber line by the LTU. When the handset is lifted, contacts in the cradle switch unit close, which causes a current to flow from the LTU to the handset. The subscriber proceeds to enter the number of the called party using the telephone keypad, which is connected to the dialer. When each key on the keypad is pressed, a pair of single-frequency tones is applied to the line by the dialer. This type of dialing is called dual-tone multi-frequency, DTMF, keying. Pressing the digit 5 causes two tones to be applied, one of frequency 770 Hz and the other of 1336 Hz. At the exchange end, a bank of filters, each of which detects just one of the tones, is used to determine the string of dialed digits that have been entered by the subscriber. The called number is then passed to the exchange control processor. Then it proceeds to initiate the setting up of a connection through the switching network to the called party. The ringer circuit is connected across the subscriber line to alert the called subscriber of an incoming call. The LTU of the called party applies a series of short bursts of a pair of low-frequency, ringing, tones to the line. The lifting of the handset by the called subscriber causes a current to flow as before and, in response, the LTU removes the ringing tone. Both subscribers are aware of this, and the conversation then starts. The subscriber line comprises only a single pair of wires. The same pair of wires must be used to transfer the two analog speech signals associated with the call. A unit called a 4-wire to 2-wire hybrid is present in order for each subscriber not to hear their own voice when speaking. The output from the microphone in the handset, A, is passed to the subscriber line for onward transmission to the other party simultaneously. Within the hybrid, the same signal is subtracted from the combined signal received from the line, A plus B. Only the signal received from the other party, B, is fed to the speaker in the handset. Have a look at these review questions. Some of them are posted in BB for you to answer. This is the continuation of questions for you to ponder. This and following section present the concepts pertaining to modems and modulation schemes. All these slides have self-explanatory points for you to go through and understand, and hence there will no voiceover for the slides that follow.